Question 1. Gareth is running a game stall at his school fete. In his game, a player must flip a coin and spin a fair four-sided spinner. Sections of the spinner are labelled 1, 2, 3 and 4 shown below. Let's have a look at this for a minute. There's a coin, so if somebody flips a coin they can get a head or a tail. If somebody spins the spinner they can get a 1, 2, 3 or 4. Part A1 asks us to write down all the possible outcomes of this game and tells us one and shows that one has been done for us. In order to write down all the possible outcomes systematically, I'm going to do a sample space diagram, which is a table, and down the column I'm going to write down the outcomes of flipping a coin, which are a head and a tail. Along the top I'm going to write down the outcomes of spinning the spinner, which is a 1, 2, 3 or 4. So the possible outcomes in this game are getting a head and a 1, a head and a 2, a head and a 3, a head and a 4. Or we can get a tail and a 1, or a tail and a 2, or a tail and a 3, or a tail and a 4. So these are all the possible outcomes of tossing a coin and spinning the spinner. As you can see, we have 8 outcomes. So that's the answer to part 1. Part 2 says a player wins a prize if the coin lands on a tails and the spinner shows the number 4. It tells us that Azzy plays the game once. It asks us to calculate the probability that Azzy wins a prize. So we have to calculate the probability of Azzy getting a 4 and a tail. If we go back to our sample space diagram, we can see that there's only one time that a tail and a 4 can be achieved. So that's one successful outcome out of a possible 8 outcomes. So the probability of Azzy winning the game is 1 successful outcome out of 8. Part B of this question says that Keris says the chance of throwing a 3 on an ordinary dice, on an ordinary 6-sided dice, is higher than the chance of throwing a 6, because a 6 is the hardest number to get. Is she correct? Well, I'm going to work out the probability of getting a 3 on a dice. There is only one 3 out of a total of 6 numbers. So that's one successful outcome out of 6 possible outcomes. I'm going to work out the probability of getting a 6 on a dice. There's only one 6 on a dice out of a possible 6 numbers. So that's one successful outcome out of 6 possible outcomes. So the probabilities are equal. So the probabilities are equal for a 6 and a 3. So Keris is incorrect.